Hi, Mr. Richards here, coming to you today from beautiful sunny Ohio. Today's lesson is on parallel and perpendicular lines. Well, a couple things about parallel lines. One is that every set of vertical lines is parallel. Of course, these have undefined slope. When we deal with non-vertical parallel lines, where parallel lines never intersect, they never touch, our non-vertical parallel lines, these have the same slope. To write an equation of a line that is parallel to a given line, you're going to do two things. First, find the slope of a given line, and then substitute the provided point from the line that you're going to write an equation for, and the slope from that original line into point-slope form. Let's take a look at how this looks in a few examples. We want to write an equation in slope-intercept form for the line that passes through 4, -2, and is parallel to the graph of y equals 1/2 x minus 7. Well, our first step, remember, is to figure out the slope. Now, the slope of the line with the equation y equals 1/2 x minus 7 is, well, this is already in slope-intercept form. And so our slope here is with the x, so it's 1/2. Well, the slope of this original line is 1/2, and the slope of any line that is parallel to 1/2 x minus 7 is just the same, 1/2. Now we want to find the equation in slope-intercept form. Well, the slope of our line is going to be 1/2, and we're going to use the provided point here, 4, -2, to come up with the equation in point-slope form first. Y minus y1 equals m times x minus x1. Now remember, this ordered pair here is our x1, y1. So as we substitute in, this is going to be y minus a -2 equals our 1/2 times x minus 4. Now here I have a minus and negative, and I want to simplify that. So that's going to be y plus 2 equals 1/2 times x minus 4. Now, this is the equation of the line in point-slope form. My question's asking for slope-intercept form, so I need something y equals mx plus b. Well, in order to do that, I need to distribute this 1/2 and end up, well, I still have y plus 2 on the left, equals 1/2 x. 1/2 times the minus 4 is minus 2. Now I need to get this y alone, so I'm going to subtract the 2 here from both sides and have a result of y equals 1/2 x minus 4. And that is in y equals mx plus b form, which is slope-intercept. So that's our answer. So when we take a look at what we did, we established that the slope of the given line was 1/2, and so the slope of any line parallel to it is also going to be 1/2. We then took the point and that slope, wrote our equation in point-slope form, distributed and simplified in order to get it into slope-intercept form. Let's take a look at one more example similar to this. In this equation, though, we're going to write it through the point 2, 3 with our equation y equals 1/2 x minus 1. Well, again, we'll start off by looking for the slope, and the slope here again is 1/2. So the slope of any line parallel to that is going to be the same, which is, again, 1/2. So our slope m is 1/2, And our ordered pair that we're going to use here is 2, 3 this time. And that's going to be x1, y1. And so we'll start off once again in point-slope form. Y minus y1 equals m times x minus x1. That's our point-slope form. Make our substitutions in. Y minus 3 equals our slope of 1/2 times x minus 2. Now, I'm in point-slope form already. Let's go ahead and distribute. On the left side, we're still with y minus 3 equals 1/2 x minus 1. As 1/2 times the minus 2 is -1. Finish this off by adding 3 to both sides. And y equals 1/2 x plus 2. And that's our equation in slope-intercept form. Lines that intersect at right angles are perpendicular lines. So, we have two lines here, and if they intersect at right angles, these are said to be perpendicular lines. Now, perpendicular lines have special properties. Parallel lines have the same slope. Perpendicular lines do not. The slopes of non-vertical perpendicular lines are opposite reciprocals. Now, what's that mean? Well, think about reciprocals. If we have a line that has a slope of 3/4, well, think about what's the reciprocal of that. Well, 4/3, but the opposite of that is a -4/3. So if one line had a slope of 3/4, the line perpendicular to that would have to have the slope of -4/3. Now what we can do is use slope to determine whether or not two lines are perpendicular by seeing if the two slopes are opposite reciprocals. The height of a trapezoid is the length of a segment that is perpendicular to both bases. In trapezoid ARTP, segment RT and segment AP are bases, and those are RT and AP. And we're being asked, can EZ be used to measure the height of the trapezoid? Well, if it could, that means it would need to be perpendicular to both the bases. So what we're going to do now is to calculate the slopes of, we'll do RT and EZ. Because if we calculate the slopes, and if the slopes are opposite reciprocals, that would mean that the two are perpendicular. Let's start with RT, and let's get the points for R and T, and we'll need the points as well for E and Z. R is at -5, -3, and T is at -1, +1. E is at -3, -1, and Z is at -2, -8. Now if I go to calculate my slopes, I can label my x1, y1, and my x2, y2. And using our slope formula, m equals y2 minus y1 over x2 minus x1. Our y2 is 1 minus -3 over -1 minus -5. Well, this simplifies into 4 over 4, which is just 1. So the slope of RT is 1. So I'm going to look for now the opposite reciprocal for EZ for this to be perpendicular. Well, we can label our E x1, y1, and our z, x2, y2. So as we calculate the slope here, slope formula is y2 minus y1 over x2 minus x1. And that's going to equal negative 8 minus negative 1 over negative 2 minus negative 3, which simplifies into negative 7 over 1, which is just negative 7 equals m. Well, 1 and negative 7 are not opposite reciprocals, so our answer for this question, can EZ be used to measure the height of the trapezoid, is, well, no. The slopes of RT and EZ are not opposite reciprocals and are not perpendicular. Now, moving on to are the bases parallel? For the bases to be parallel, the slopes of RT and AP would have to be the same. Well, I already know that with RT, my slope is 1. So I'm going to need the slope of AP to also be 1, so for me to say that the slopes, or the bases, are parallel. Let's go ahead and calculate it. If we look here at AP, we again need to find the points for A and P. A is at negative 4, negative 10, and P is at, actually not negative 6, but 6, 0. And if I label these x1, y1, and x2, y2, when I go to calculate the slope one last time on this problem, y2 minus y1 over x2 minus x1, or y2 is 0 minus negative 10 over 6 minus negative 4. That simplifies into 10 over 10, which is, hey, 1. So the slope of AP is 1. So to answer our question, are the bases parallel? This time we can say, yes. The slopes of RT and AP are the same, so the segments are parallel. So for perpendicular lines, you need opposite reciprocals. For parallel lines, you need the same slopes. We had it in A. We didn't have it in A, but we had it in B. The graph shows the diagonals of a rectangle. Determine whether segment JL is perpendicular to segment KM. Well, again, we're looking for opposite reciprocals here for the slopes, so we need to calculate the slopes of JL and KM. And this time it's nice because we already have the points. Don't have to count this time. J is at 2, 6. L is at 6, 1. And if we label x1, y1, and x2, y2, so we can calculate this slope, m equals y2 minus y1 over x2 minus x1, 1 minus 6 over 6 minus 2. We end up with negative 5 over 4 for JL. What about KM? Well, our K is 6, 6. Our M is 2, 1. And again, label these points x1, y1, x2, y2. So we can set up our slope formula, y2 minus y1 over x2 minus x1. y2 is 1 minus 6 over 2 minus 6. And that simplifies into negative 5 over negative 4, which is a positive 5/4. Well, as we compare these slopes, we have negative 5/4 and positive 5/4. So we have half of what we need. We certainly have opposites, but we do not have opposite reciprocals. So our answer here is no. JL is not perpendicular to KM, since the slopes are not opposite reciprocals. We have the opposite part down, but we would need Km to be a positive 4/5 for this to work. Now determine whether the graphs of 3x plus y equals 12, y equals 1/3 x plus 2, and 2x minus 6y equals negative 5 are parallel or perpendicular, and explain. The way we're actually going to solve this problem is by graphing. So if we have our 3x plus y equals 12, if we work to get that into slope-intercept form, so we can more easily graph this, we would have y equals negative 3x plus 12. When we go to plot this on our graph, our y-intercept, wow, where'd that come from? Our y-intercept is at 12, and our slope is negative 3, which is the same thing as negative 3 over 1, so we're going to go down 3 and over 1, down 3, over 1, down 3, and over 1. And that should be enough of a sketch to be able to connect these points as neatly as we can on our graph. For our next equation, we're already in slope-intercept form with our y equals 1/3 x plus 2, so we don't have any extra work to do here. We can graph our y-intercept at 2. And what 1/3 means is we're going to go up 1 to the right 3. So we'll go up 1 to the right 3. Up 1 to the right 1, 2, 3. Up 1 to the right 3. And of course we could go down from the y-intercept and back 3 as well. And down 1 and back 1, 2, 3. That's more than enough to be able to get a sketch of this graph here. So as neatly as you can, connect the points. And this is the equation y equals 1/3 x plus 2. And the first one we'll also label here as the equation 3x plus y equals 12. Now for our 2x minus 6y equals negative 5, we have a little more work to do with that one. We have 2x minus 6y equals negative 5. Well, let's subtract the 2x from both sides. We're left with negative 6y equals negative 2x minus 5. Divide everything by that negative 6, and y is going to equal 1/3 x plus 5/6. Well, what this is telling us now is that we have a y-intercept at 5/6, which is just below the 1, and our slope we're going to go up 1 and over 3. So up 1 over 1, 2, 3. Up 1 over 1, 2, 3. Up 1 over 1, 2, 3. We can also go down 1 and over 3, and down 1 and over 3. And again, now we have more than enough points to be able to draw a decent sketch of this line. And there it is, right there. That's our line, 2x minus 6y equals -5. Now, do we have parallel or perpendicular lines? And looking at this, it looks like you have a little bit of both. So what can we write in our explanation? Well, we can say that y equals 1/3 x plus 2 is parallel to 2x minus 6y equals -5 because they have equal slopes. And of course those equal slopes are 1/3, and you can see that in the y-intercept form where they have equal slopes at 1/3. Now the other equation, 3x plus y equals 12, is perpendicular to both, since its slope is an opposite reciprocal. When you look at the slopes of the red and the blue line, that was 1/3. Well, what's the opposite reciprocal? The reciprocal is 3. The opposite reciprocal is -3, and sure enough, that's our slope. So we finally have an example of what a slope that's an opposite reciprocal looks like. Now, after working with perpendicular and parallel lines, we get to write an equation of a line that is perpendicular. So write an equation in slope-intercept form for the line that passes through 4, -1, and is perpendicular to the graph of 7x minus 2y equals 3. Well, just like with our parallel lines, our first step is going to be to find the slope of our given line. So right now we have 7x minus 2y equals 3. We need to get that into slope-intercept form to find the slope. So if we subtract 7x from both sides here, we're left with -2y equals -7x plus 3. Now we can divide everything by -2. And we're left with -7 divided by -2 is a positive 7/2 x plus 3/2. So y equals 7/2 x plus 3/2. And what is our slope? Well, 7/2. So the slope of the perpendicular line now is the opposite reciprocal of 7/2, which is going to be the opposite. The reciprocal is 2/7. The opposite reciprocal is -2/7. So now we need to find the equation of the perpendicular line. And again, we're trying to get this into slope-intercept form. Now, our slope now is going to be -2/7. The point we're using is 4, -1. And again, I can call that x1, y1, since I'm going to once again start in point slope form. Y minus y1 equals m times x minus x1. Make your substitutions in. Y minus -1 equals -2/7 times x minus 4. Let's go ahead and simplify y plus 1 equals negative 2/7 times x minus 4. We need to distribute here. I'm going to rewrite this up here. We have y plus 1 equals negative 2/7 x plus, we'll have 8/7. Now we can subtract this 1 from both sides. And subtracting 1 in this case is the same thing as 7/7. So y equals negative 2/7 x plus 1/7, and that is our equation in slope-intercept form. As we look to do this one more time, write an equation in slope-intercept form for the line that passes through negative 3, negative 2, and is perpendicular to the graph of x plus 4y equals 12. Let's first once more find the slope. So we have x plus 4y equals 12. Let's get this into slope-intercept form. We can subtract this x from both sides. And our result is 4y equals negative x plus 12. If we divide everything by 4, we'll rewrite this equation over here as y equals negative 1/4 x plus 3. So our slope is right here at negative 1/4. So we're going to be looking for the opposite reciprocal of negative 1/4. Well, the reciprocal is 4, and then the opposite of negative is positive, so 4. Well, if our slope's going to be a positive 4, and the point we're going to be using is negative 3, negative 2, we can start our equation in point-slope form. Y minus y1 equals m times x minus x1. Remember, this is at the x1 and y1 in point-slope form, so y minus negative 2 equals 4 times x minus negative 3. Simplify that before we distribute. Y plus 2 equals 4 times x plus 3. And now you can distribute this 4 to the x and the plus 3. You end up with y plus 2 equals 4x plus 12. And now subtract that 2 from both sides. And I'm going to have to write this up above again. Y is going to equal 4x plus 10. So, when we're looking for perpendicular, we do something very similar to parallel, except once we get the slope, we're looking for the opposite reciprocal. And then use your slope, use your point, use point-slope form, and simplify to get it to slope-intercept. Let's move on to our concept summary. Basically, parallel lines are two non-vertical lines are parallel if they have the same slope. So these two lines have the same slope. Whereas perpendicular lines, they meet at right angles, and it's saying the product of their slopes is negative 1. Well, if you think about what that means, if we have 3/4 as one of the slopes, and the opposite reciprocal is negative 4/3, a way to test whether or not something's an opposite reciprocal is to simply multiply them, and you'd get negative 12 over 12, which equals negative 1. So any number's opposite reciprocal once you multiply is going to be negative 1. So that's another way, besides just looking at it, to see whether or not two slopes are opposite reciprocals. That's it. Good luck.